But ready, set. And with weak acids and bases, only ionizes and dissociates partially. Remember, we are looking for equilibrium. With acid and bases, we are looking for equilibrium. So we need to equalize. So if it's a weak acid or a weak base, it will equalize at a specific pH with the ions. Strong versus weak acid bases. Here's more of an example. You see how the weak one, you have HF and H plus and F minus. Well, over here you just have it fully. It will either be OH negative or Na plus. That is how you dissolve completely, dissociate completely. You don't have them still together. Well, if it's a weak, it won't fully dissociate, so some of it will be stuck together as HF. Speaking of which, you should never touch HF because this is very bad stuff. So just because it says weak acid does not actually mean it's safe. Electrolyte. All acid and bases are electrolytes because they form ions when dissolved. Electrolytes are ions which allow a solution to conduct electricity when dissolved in water. You can make electricity like this. Funny? Strong acids. You need to know what strong acids are. So go ahead and write this down for number 4. Write this down. You need to know HCl, HNO3, H2SO4, which is sulfuric acid, HClO4, HClO3, HBr, HI. You actually have to know the name. Hydrochloric acid, nitric acid, sulfuric acid, bromic acid. And this name is spacing me for a second. It will come to me. I'll get back to that one. Strong bases are right here. Make sure to know these. Some common ones: sodium hydroxide, potassium hydroxide, lithium hydroxide. Where OH is just hydroxide. So calcium hydroxide, lithium hydroxide. That's the trend that you need to know. You do need to know the strong bases and the strong acids. It will be on the test. Concentration versus strength. Concentration is how much acid or base is actually dissolved. Strength describes how much of the acid or base dissolved is dissociated or ionized. So when we're talking strength, we're talking about how it is disassociated. While concentration, how much of the acid and base is actually dissolved. How much did you dissolve in that solution versus the ions? Did they dissociate all the way? That is the difference. Which is the most concentrated acid? Which is the strongest acid? Go ahead and answer this question and for number 5. What might happen if an acid is added to a base or vice versa? What do you think will happen? It will neutralize. The ions will interact. An acid will neutralize a base, giving a salt and water as present. So H3PO4 plus KOH equals H2O, which is water, plus KPO4. What type of reaction is this? Double replacement. Think what we know. Use what we know to help you. Go ahead and answer this for number 6. Neutralization. A common experiment is a titration, which we will be doing in this unit. A salt is any compound that can be derived from the neutralization of an acid or a base. The word neutralization is used because the H plus and OH are destroyed or neutralized to make water and a salt. You'll get water and a salt. Remember this. All neutralization reactions are double replacement, like I previously said. Double replacement, what we know. Always go back to what we know, and you won't be able to forget any of your information from last test. So please don't just try to get that out of your mind. You will need it. The HCl plus NaOH, the CO, double replacement, goes to the NaCl, and that becomes water. Water can also be written like that. I had that written like that on the test, and it tripped some of you guys up. That's okay. So you have your salt and water as your product. That's just mapping out exactly what's happening. Example of a double replacement neutralization. How to fix an upset stomach. How many people have had it? This is the process. You take some MgOH2s, which is basically Tums. Your HCl, I don't know if you guys know this, but your body has HCl right around here. And basically what you're doing is combining the two. Salts. If a salt is a result of a strong acid and strong base, weak acid, weak base, and a strong base, different strengths of salts. If it's completely, it's going to be stronger than it. It doesn't, if you're doing it weak and strong base, weak base. What kind of salt would the following neutralization reactions produce? Did you start with a strong acid or strong base? Don't worry about that. And again, here's your strong acids, and that is the lecture.